Okay, so number 10, I'm actually going to let you read on your own because I am not good at pronouncing names, and that one's a little rough for me. But basically, it talks about there's a shot putter, and the chart shows the distance as compared to the height that he throws the ball. Now, when you read the problem, it doesn't tell us what type of regression model to make, but it tells us to use this information to determine the height of the ball if it reaches 80 meters. Okay, so in order to figure out what type of regression to make, I mean, first of all, if you think about a ball goes up and back down. So you could, think about what that would look like. But if you want to get a better idea, we can really just kind of sketch a graph. It doesn't have to be anything great. We'll just make this our distance, and we'll make this our height. And if you want to plot the points, it looks like the highest distance we have is 67. I'm just going to say 10, 20, 30, 40, 50, 60, 70. And it looks like the highest height we're going to have to go to is 26. I'm just going to number by fives. So 5, 10, 15, 20, 25, and 30. Okay, so let's just plot each of these points. All right, so we have the points 7, 8, and they're just going to be estimations. So 7, 8, I'm going to say is about right here. 20, 15 is about there. 33, 24. So you're just estimating just to get a general idea of what this graph is going to look like. 47, 26, I'm going to say is about here. And then we could see what happens is when we go to 60, 24, the graph actually starts coming back down a little. So if you flip back a few pages in your packet and you want to take a look at what this graph looks like, some of you might at first be thinking logarithmic by the way it grows, but a logarithmic would continue to grow and then kind of level out. So a logarithmic would kind of come like this. Since our graph is going back down, it actually is following a quadratic model. All right, so we're going to do a quadratic regression equation. Okay, so you can first go to stat in your calculator, clear out whatever lists are in there, and let's plug the distance, the first column, into L1, and let's plug the height, the second column, into L2. If you need a little more time to plug those in, feel free to pause the video, and you can always hit play again when you're ready. Okay, so then what you're going to do is when you go to Stat and over to Calc, we're going to go down to Choice 5, which says Quad Reg. Okay, so we're making a quadratic regression equation. Okay, so now when you hit Enter, and on the next screen you scroll down to Calculate and hit Enter, this is what you should see on your screen. And you can see a quadratic follows the form y equals ax squared plus bx plus c. So we're going to have to take the a, the b, and the c and plug them in to create a regression equation. Okay, so since the question says absolutely nothing about what to round to, it really just says what would be the height of the ball if it travels 80 meters. Well, I'm looking at all of these heights here, and they're all whole numbers. So I'm thinking our final answer, we're going to round to the nearest whole number. So if we take the values of a, b, and c and plug them into our equation, if we round those to the nearest 4 decimal places or more, that should be sufficient to come up with a correct answer rounded to the nearest integer in the end. Okay, so let's write this equation. So y equals, in place of a, I'm going to plug in negative 0.0111 x squared, and then plus our b is 1.0596, and we have an x after that, and then plus our c is 0.2422. Now, technically, if you didn't want to write out the equation with x's in there, you really didn't have to show this step because they want us to figure out the height of the ball if it travels 80 meters. They want to know when the x value is 80. So if you had just jumped right into substituting each of those x's with an 80, that would be totally fine to get full credit. Okay, so let's rewrite that with all of our x values of it as an 80. And then what you can do is you can just plug this into your calculator. So when I'm plugging it into my calculator, it looks like I'm getting about 13.97. And I think if you plug in the entire values of A, B, and C that are given, you get 13.96. So either way, that's going to round to a height of 14 meters to the nearest integer. Okay, at this point, I'd like you to just take a few minutes and do the ones that we skipped, numbers 6, 7, and 9 on your own. And when you finish each example, you can just play the video, and there will be an answer key for you on there. Okay, in number 6, they asked you to write a power regression equation. So I showed the calculator steps right here, and this is what we wound up getting. And then for part B, they wanted you to predict the depth of the water at 2 minutes. So we didn't want to plug in a 2 because if you look in the chart, the time is recorded in seconds. So we plugged in 60 seconds instead. And to the nearest tenth, which they wanted, is 6.7 feet. Number 7 didn't give us a chart, but, I mean, as you read through, you could just make your own chart. So that's what I did over here. And you can see the calculator steps up here. They wanted you to do a power regression for this. So here's what I got for my power regression. Even though they didn't break it up into a part A and B, I just did that so you could see what was what. And they wanted you to use this equation to estimate the number of seconds it would take for her to complete her 10th lap. So I just replaced the x, which is the number of laps, with a 10, and I got 58.9 seconds to the nearest tenth. Number 9 was very hard to fit on the paper. Even though it said to round to the nearest thousandth, we had some big numbers here. But you could see the calculator steps right here. They wanted a quadratic regression equation. So this big, long equation right here is what we got. And if you see, even the C, even though it was a whole number value on the calculator, we did, have to write 0.000 because they wanted it to the nearest thousandth. Honestly, I doubt this. I'm sure this would have had decimals at the end, but the calculator only puts up to 10 digits, so it wouldn't have fit anyway. But then for part B, they wanted you to use the model to predict the number of AIDS cases for the year 2006. So just replace the X with 2006. And although they don't say what to round to, when you're talking about the number of AIDS cases, there could only be a whole number of cases. So I wound up with 51,923.